College enrollment. The statistical abstract of the United States reported that 66% of students who graduated from high school in 2012 enrolled in college. 100 high school graduates are sampled. Let X be the number who enrolled in college. Use the normal approximation to binomial with continuity correction to find the probability that at least 75 students enrolled in college. To use the normal approximation to binomial, we first need to verify the requirement. But first, we see that x is a binomial distribution with the number of trials, or in this case, the number of high school graduates is fixed 100, and the probability of success, in this case, success means they enrolled in college. The probability of success or that they enrolled in college is 66% or 0.66. And so n is 100 and p is 0.66. The condition for the normal approximation is that n times p, where n is 100, p is 0.66. This is 66. And we see that n times p is at least 10, greater than or equal to 10. We also need to check n times 1 minus p. N is 100 and 1 minus p is 0.66. This is the same as 100 times 0.34, which is 34. 34 is again at least 10, greater than or equal to 10. And so both conditions are satisfied. We can use the normal approximation for this binomial. The next step is to find the mean mu. Mu is n times p, but n is 100 and again p is 0.66, and so the mean is 66. The standard deviation is the square root of n times p times 1 minus p, where n is 100, p is 0.66, and 1 minus p is 1 minus 0.66 or 0.34. And we see that this is 4.737. Since the standard deviation is small, we round it to 3 decimal places instead of the usual 2 decimal places. Next, we draw the normal curve and label the mean and the standard deviation. The mean is 66 and the standard deviation is 4.737. We then locate the x value that is relevant to the binomial probability problem. The relevant value in this case is 75 because we're looking for the probability that at least 75 students enrolled in college. We then locate the number 75 on the horizontal axis. The mean in the middle is 66, so 75 must be on the right hand side. We draw the vertical line, connect the point 75 to the density curve. And we want at least 75, meaning we want 75 and more. In symbolic form, we're looking for the probability that x is greater than or equal to 75, at least 75 for the binomial distribution. But with the normal approximation, we need to add 0.5 and subtract 0.5. Go to the right half unit and go to the left half unit. If we add 75 to 0.5, we get 75.5. And if we subtract 0.5 from 75, we will get 74.5. The next part is to determine whether 75 is included in this probability. And the answer is yes, because at least 75 includes 75. At least 75 means 75, 76, 77, all the way to 100. And since we want to include 75 in this case, we would need to shade everything on the right hand side of 74.5. If we were to use 75.5, then we would miss 75. And again, that is the reason why we need to correct this, so that the normal approximation is now the probability of x greater than 74.5, not 75, not 75.5. We then use the normal calculator to evaluate this probability. This is only one-sided probability, so we would choose the standard feature. We type in the mean 66, the standard deviation 4.737, and then we choose the inequality greater than or equals. We input the x value 74.5 with the continuity correction. The probability is 0.0364, and that is the probability that at least 75 students enrolled in college. And so again, that probability is 0.0364 rounded to 4 decimal places. Next, find the probability that more than 75 students enrolled in college. This is another probability problem, so we will draw another bell-shaped curve, label the mean 66 and the standard deviation 4.737. The x value that we are interested in is still 75, and we want more than 75, so we will shade everything to the right of 75. The next question is we need to correct it. We always add or subtract 0.5. If we subtract 0.5, we get 74.5. And if we add 0.5 to 75, we get 75.5. The next question is to determine whether 75 is in this probability in symbolic form. We're looking for the probability that x is more than, greater than 75 for the binomial distribution. But this time we're going to do a continuity correction. And so this is the probability of x greater than. The question is, do we want to include 75 in this case? And the answer is no. More than 75 includes 76, 77, 78, and all the way to 100, but it did not include 75. And so how do we shade this so that 75 is excluded? We need to start shading this region starting with 75.5. And so the continuity correction is p of x greater than 75.5. And then we use the normal calculator to finish the computation. This is again one-sided probability, so we use the standard feature. The mean is 66 and the standard deviation is 4.737. We still choose the greater than or equals inequality, but this time we would input 75.5. Hit compute. The answer is 0.0225. And so again, the probability that more than 75 students enrolled in college is 0.0225. It is a little bit less than what we had earlier. Next, find the probability that at most 75 students enrolled in college. Again, a different probability problem. Draw the normal bell-shaped curve. The mean is still 66 and the standard deviation is 4.737. The value that we are interested in is 75, which is on the right of the mean 66. This time, we want at most 75. At most 75 meaning anything up to 75 and including 75. And so we're interested in the area on the left-hand side of 75. Everything on the left-hand side of 75. Next, we need to determine the continuity correction by subtracting 0.5 and adding 0.5 to the value that we are interested in. 75.5 on the right and 74.5 on the left. Same question. Do we want to include 75 in this case? And again, the answer is yes, because at most 75 is from 0, 1, 2, 3, all the way to 75, including 75. So how do we shade it? How do we correct this shaded region to include the number 75? And we have to go past 75 up to 75.5 to make sure that we include the number 75. We're looking for the probability of x less than or equals to 75 for the binomial. But using normal approximation to binomial with continuity correction, we will change it to p of x less than or equal to 75.5 to include 75. We then use the normal calculator to finish the job here. Left side only, so we would use the standard featured. The mean is 66. The standard deviation is 4.737, but this time we choose less than or equals because we want the left area. The x value is now 75.5. Then we hit compute. We get the probability of 0.9775. And so the probability that at most 75 students enrolled in college is 0.9775.